Okay, in this video, we will see about the kinetic theory of gases. The kinetic theory of gases, the assumption made by the kinetic theory of gases. The first one is the internal energy of the molecule of the gas is made up of it is kinetic energy. The source of the internal energy of the molecule of the gas is only the internal energy. For example, if this is one system, in this system, if the gas molecule is contained, this system has its own internal energy. Internal energy is the sum of kinetic energy and potential energy. According to this theory, the source of the internal energy of this system is only it is kinetic energy. But here, no potential energy exists in these gases because potential energy is possessed due to attraction or repulsion of molecules. Due to interaction of molecules, potential energy exists. But here, there is no attraction or repulsion formed between the molecule of the gas. Because of this, there is no potential energy here in the system. Therefore, the total internal energy of this system is equal to it is kinetic energy, the sum of the kinetic energies produced by each molecule of the gas equal to the total internal energy of this system. Only kinetic energy exists. This is the first assumption. The second assumption is the collision formed between particles and particles. That means the collision formed between molecules and the molecule of the gas and between molecules and the wall of the container is perfectly elastic collision. Perfectly elastic collision. What does it mean? Elastic collision, an elastic collision, head-on collision, glancing collision, types of collision. Here, the collision formed between particle of gases and particle of gases and between particle of gases and the wall of the container is perfectly elastic, means the collision formed between particle and particles after collision, they never stick together, they separate perfectly. If so, the collision is elastic collision. They have no common velocity after collision. If so, the type of collision is elastic collision. In elastic collision, the two bodies are stick together after collision. The two bodies have, if they have common velocity after collision, then it is said to be an elastic collision. But these particles, after collision, they separated. Separated. They have no common velocity. They do not stick together after collision. Because of this, it is said to be elastic collision. This is the second assumption. The other assumption is the volume occupied by a single particle is negligible when it is compared with the volume of the whole system or the volume of the whole gas. The volume occupied by a single molecule of gas is negligible when it is compared with the volume of the whole system. And there is also another assumption that is stated by the kinetic theory of gases. The other point is the pressure exerted by a gas inside a container. Look, this is a container, a cube which has length L. Inside this cube, a single molecule which has mass m, molecule of gas which has mass m is placed. A single molecule of gas is placed. Let's say, okay, sorry. Let's say this is a cube. Inside this cube, a molecule of gas which has mass m is placed. The length of the cube L, L, L. In this topic, we will see about the pressure exerted by a single particle which is contained in the cube. So, this pressure, the source of pressure exerted by a molecule is due to the momentum of the particles. The pressure, the source of pressure due to this molecule is formed from the momentum of a particle. Let's say a molecule is moving towards the right, and change in momentum formed by a molecule is equal to momentum final minus momentum initial. A molecule is moving towards the right and form a collision within the wall of this container towards the right, and form a collision within the wall of the container and returns back. Let's say this is x-axis. Along x-axis, move to the right and returns back. Because of this, the direction of these momentums are opposite. One towards the right. After collision, the momentum formed is to the left. Therefore, this is equal to mass times velocity of the molecule of a gas along x-axis minus into minus. This means since the two momentums are opposite in direction, here we use minus sign, minus mx. Minus minus, this is plus, this is equal to twice of mvx is equals to change in momentum. Now, change in time, this means the total time used by a molecule of the gas while it covers this distance, one side of L, and returns back, is equal to twice of the length of this side over the speed of a molecule. The speed of the molecule is never changed, constant speed after collision and before collision. This is also another equation, but from the second law, Newton's second law, that means from Newton's second law, force is equals to change in momentum over change in time. This is Newton's second law. So change in momentum, use 2 times mass times the speed of a molecule of the gas along the x-axis instead of changing momentum, and instead of changing time, use this. This is equal to 2mvx over 2l over vx. This is simply derived from speed is equals to distance over time. Distance covered by the molecule of the gas is twice of L, twice of the length of the cube, over time. From this we should have time is equals to twice of L over speed. That's the same, over speed. So, force is equals to twice 2 cancelled by 2 m Vx square over L. This is force. This is force. But pressure is equals to force over area. Force mvx square, velocity along x-axis square over the length of the cube. Use this instead of force. mvx square over area times L. Area times L. This L. So pressure is equals to mvx square over AL. Area times length is volume. This is the pressure exerted by a molecule, a single particle. But for any particles, if any particles are placed in this cube, the pressure exerted by n particles is given as pressure exerted by n particles equals to n times mvx square over v. This v is volume over v. Now here this cube has 3 dimensions: x, y, and z dimension. So a molecules inside this container can exert pressure along x, along y, and along z. Here we calculate only pressure exerted by the molecule of the gas along x-axis. But in 3D, if the average velocity, or simply velocity, resultant velocity, let's say average velocity square is equals to velocity along x square plus velocity along y square plus velocity along z square. For 3D, the resultant velocity square is equals to velocity along x square plus velocity along y square plus velocity along z square. But the molecule of the gas have the same velocity, the same speed along x, along y, and along z, constant speed. This means v along x square is equals to v along y square is equals to v along z square. Therefore, v average is equals to v, let's say this vx, vy, vz change into vx, because vx square means vy square means vx square, because they are equal. Vz square means vx square. Therefore, vx square plus vx square plus vx square, because vy square means vx square, because they are equal. Vz square means vx square, because they are equal. Therefore, v average square, the resultant velocity is equals to 3vx square. So vx square is equals to 1 over 3 times average velocity square. Average velocity square. Look, velocity along x square is equals to 1 over 3 times average velocity square, or resultant velocity square. So it is possible to substitute 1 over 3 times average velocity square instead of vx square. Therefore, substitute 1 over 3 times average velocity square instead of velocity along x-axis. Therefore, pressure is equals to n times mass times v average square over 3 times volume. average velocity square. Average, V average is equals to, let's say, mean velocity. Let's substitute average velocity by C mean. Therefore, V average square is equals to C mean speed of the molecule of the gas. Let's substitute this by this mean speed square. So pressure is equals to Nm times C square over 3V. 3 times velocity, 3 times volume. So this is equal to 1 over 3 times number of molecules times mass of molecule over volume times mean speed square. Mass over volume. This is density for a molecule, a single molecule. For any number of molecule, density is equals to number of molecule times mass over volume. Therefore, number of molecule times mass over volume can substituted by the total density of the gas. Therefore, this is equal to 1 over 3 times density times mean speed square, which is equals to pressure exerted by a gas. The pressure exerted by a gas contained in a container, a cube, is equal to 1 over 3 times density of the gas times mean speed square.